Good question. Good question. Number 19. Okay, so at this point, you guys are not very good with your radian measures. So I think it would be smart of you to convert this to degrees. So pi over 3 radians. How do I convert that to degrees? What do I multiply by?
360 or 1 over 360.
180 over pi. Yep. I figured you meant pi radians, so yeah. Yep, that's a good idea. Anything cancel out? The pi's and the radians, yep. 3 goes into 180 how many times? 60 times. Ding, ding, ding. So this question is really the same as this question, the sine of 60 degrees. Now, we're not reaching for a calculator. It says without using a calculator. So I'm guessing we're going to have to go back to what we studied last week. We reminded ourselves of what a 30, 60, 90 triangle looks like. We said the short leg was 1. How do we get the hypotenuse? Oh, save that one. How do we get the hypotenuse? How do we get the hypotenuse? We multiply by what? 2, right? You multiply by 2. Now what do we do to get the long leg? Multiply by radical 3. Okay? Okay, so to get, you double it to go from here to there. You multiply by radical 3 to go from there to there. Everything's based on the short leg. All right. So now can you answer the question now that you have the triangle in front of you? So we want sine. Let's see, what is that? Is that opposite, adjacent, hypotenuse? What is that? It is opposite over hypotenuse, which is radical 3 over 2. Yes, sir.
How do you know this?
Because they told me.
Oh.
Sorry. That's all. That's the only way I would know. You're right. If they didn't tell me, I would kind of be stuck. That help? Okay, next question. Sure. I hope so. Evaluate using a calculator. Okay. Yes, I sure hope it does. Where did that come from? 19.23 degrees. Okay, maybe I can write that on screen. 19 degrees, 23 minutes. Nope, that ain't it. Come on, fire up. There we go. Okay, 19 plus what? What do I do with the 23? I'm trying to change the 23 minutes back into degrees. Divide by what? 60. So we're talking 19.383 repeating degrees. I think we wanted the cosine of that, correct? So if I were you, I would do like this. Cosine answer. That's what I would do. And yes, you can round it off to like 0.943. that help? Yeah, you just got to convert it to degrees first before you can use the cosine feature. All right. What's next? Yep. Let's see the signing first, and then I'll come back to sex. You got this. 17. Gave me cosecant 23 over 9. The other 17? What? Isn't it 17 right there? Okay. Well, I made a cool chart for you down here for number 17, so that's why I'm using it. So 17, we got cosecant 23 over 9. I just tried to make a chart for you so it'd be easy on the, yeah. Okay, so let's see here. If we've got theta down here, cosecant, that would go with which trig function? Yeah, you're right. It is hypotenuse over the opposite, right? That's my good old Cho, right? So hypotenuse would be 23, opposite would be 9. Yes, you have to know how to find those in the triangle. Now, let's suppose you didn't remember the good old Cho, but you remembered that cosecant went with sine, right? Because it started with the opposite letter. What is the sine? 9 over 23. So you got that part, and you remember in your mind, oh yeah, sine is opposite over hypotenuse. Maybe that's the direction you head. Maybe you connect it back to its sine and then go from the sine to find that. All right, so how do we find the remaining side? Yes, sir. Yeah, you're right. So x squared is equal to 23 squared minus 9 squared. Now, why did he do that? Because he was doing the Pythagorean theorem. Now, if you need to start from the beginning of the Pythagorean theorem and then work your way into solving it, be my guest. But we should have the square root of. Now, heck if I know what 23 squared minus 9 squared is. 448. I'm sure we can simplify that, but I don't really care to. Seriously. There's no good point to why we would need to simplify our, I mean, yes, we can test you on your geometry and algebra 1 skills of pulling out perfect squares, or we can get to the part of the matter which is really doing the trig. Okay, so we've got radical 448. We're just going to leave it alone. All right, so what's the cosine? Come on, adjacent over hypotenuse. You're better than this. Radical 448 over 23. Which goes with the secant, right, because they're reciprocals. Hopefully you would do 23 over radical 448. Okay, let's not worry about rationalizing it. How about your tangent? 9 over radical 448. And your cotangent. So once you know your triangle, you should be able to do everything else. Remember that how your original trig functions go with your reciprocal trig functions. Okay, next question. 41. Thank you for asking good questions, children. I appreciate it a lot. Find the angle theta that satisfies the given equation in both degrees and radians. Okay, question 41. Sine, that's opposite over hypotenuse, right? Can you look intently into the triangle and tell me what the angle is?
Please say yes.
Yeah. It's a 30, 60, 90 right triangle. That's true. Now, which angle is it? I'm going to give you a hint. It's not 90. 30. Nice job. Yeah, you see the 30? It's a whole lot like the triangle we drew before, isn't it? Now, we want it in radians also. So how do we do that? Let's see, 30, we're going to multiply by pi radians over 180 degrees, right? The degree units cancel out, right? Never let them see you sweat. Sorry, that's a Right Guard commercial. Which, I don't even know, do they make Right Guard deodorant anymore? Is that like gone?
Oh wait, no, they still make it.
They still make Right Guard? Okay, interesting. Okay, can you reduce? Do you know anything that goes into 30 and 180? 30! Nice job. How many times does 30 get into 180? 6. Yes. Pi over 6 radians. So we have the radian measure, we have the degree measure. If you'll notice, every one of these has to be based on either the 30, 60, 90 right triangle or the 45, 45, 90 right triangle. Because of one key phrase. Here it is, folks. Without a calculator. See, if I had a graphing calculator or scientific calculator to use, I would do maybe what we did back in geometry class. See, I would probably do something like this. Inverse sine of 0.5. If the sine of theta equals 0.5, then the inverse function would undo the sine and give me, oh look, 30 degrees. But if you don't get to use a calculator for this, you just get one of those little 4 functions. It has to be either the 30, 60, 90 right triangle or the 45, 45, 90 right triangle. We can't get tricky. We really can't. Yes, sir.
Test on Wednesday, we're not going to have calculators, right?
You're going to have, there's one part with and one part without. Yes. No, good question. What do we do when we deal with cotangent or cosecant or secant, like these questions in here? What are we going to do with these things? What do we need to convert them to? Well, back to the regular trig functions that we're used to, right? So if the secant of theta is 2, secant goes with which one? Cosine, right? So if secant is 2, cosine would be 1/2. So change the question. Change the question to something that you can do. Because I understand, if you're looking at it as a reciprocal trig function, it's kind of like, what am I supposed to do with this? Change it to the original. Does that make sense? Yeah. Okay. Same thing with that cotangent. Change it into tangent. It would be radical 3. And then take a look at the triangles. Oh, by the way, if it's got, like 43, if it's tangent radical 3, which of the two triangles do you think we're dealing with? Do you think we're dealing with the ones with all the radical 2s? Or do you think we're dealing with the 30, 60, 90 that which triangle is the only one that has a radical 3 in it? It's got to be the 30, 60, 90. So use some of those clues that we've talked about. Great question. And no, you can't type cotangent, secant, and cosecant on a calculator. Just have to use the idea of reciprocal. What else? Great questions. Any other homework questions? Maybe we should do 45. Let's just do 45 for fun. So you told me that was cosine theta equals 1/2. So these were the two triangles that we talked about. Oops, sorry. You have to use one of those triangles to come up with a ratio of two sides that is 1 to 2. You got 20 seconds to talk to your neighbors and figure out which triangle we're using and then which angle in that triangle. So talk to the neighbors, State Farm or otherwise. Well, they did well. What is that?
Okay, that makes sense.
I don't think anybody was going to. I don't think anybody was going to pass it. I really didn't. So it didn't matter whether it was Minnesota, New Orleans, whoever.
That was adjacent opposite.
All right, which triangle did you decide is the winner? Which triangle is the one I need? Okay, folks, which triangle? The only triangle that has 1s and 2s in it is that one right there. The other one has 1s and radical 2s. That's not what I want. Okay, so now you have to make a decision. Which one of those angles, I'll give you a hint, either 30 or 60, has a cosine of 1/2? It's the 60, thank you very much. Okay, the 60 is the only one that has adjacent over hypotenuse. It's right there, adjacent hypotenuse. Okay, so that's how we know that theta is 60. Okay, how about 47? Let's just do 47. Oh, and by the way, if you wanted me, I don't want to waste the time on converting, but because we've done converting before, but you can use the same technique that we talked about a little bit ago. Let's do 47. Okay, 47. Okay. Tangent radical 3/3. This one might stretch your brain a touch. Okay. What's the tangent of 45? What's the tangent of 45? Opposite over adjacent. It's 1, right? What's the tangent of 60? Tangent of 60. Radical 3 over 1, which is just plain old radical 3. What's the tangent of 30? Okay, the tangent of 30. You're ahead of me. I know you're right. Okay. Wrong button there. Colors. No, I don't want light blue. They won't be able to see it. Okay. Tangent of 30, opposite over adjacent, 1 over radical 3. Which one of those is radical 3 over 3? Okay. We're looking for an angle who has a tangent of radical 3 over 3. Do we think it's this one? No, that's ridiculous. Okay? We know that's not true. Do we think this is equal to radical 3 divided by 3? No, because that's exactly 1/3 of its value. Do you think this is radical 3 over 3? That's true, right? Notice they rationalized it. I was wondering if you'd pay attention to it. They did. They multiplied by radical 3 over 3. They kind of disguised it, but it is. We're dealing with 30 degrees. Yeah. Number 47 is dealing with 30 degrees. Does that make sense? Why? Okay. Yeah, they did. They disguised it a little bit. I really think, yeah. Oh, really? You're excited about that? Come on, it is a good thing.
Does it make sense we don't have to do work?
What?
Do we have to do work if we memorize some like 30 degrees and 5 or 6 or 3?
Yes, you have to show me how. Trying to cheat me out of work. Did you hear that? I don't have to show work. Yes, show all your work. Okay? Now, I do realize that you're dealing with some of the simple values on the circle. I do understand that. We'll jump off the deep end here in a little while. Any other questions for me today on homework? 4-2 homework?